Hey there, it's Max, and we just talked about how to do the FT poisoning technique on the tcache, and now we're going to talk about how to do it on Fastbin. So, practically speaking, the main difference is that there's a check that is being done on the chunk size. In particular, with the tcache version, you can put an arbitrary pointer, it doesn't care. But the Fastbin will actually check to make sure that the size of the chunk is going to match what's being taken out of the particular bin. So this limits the situations in which this is useful. The other difference is, for some reason, the FD pointer points to the chunk instead of the memory. If you remember, there's like the thick line in the chunk diagram at here. And for whatever reason, the tcache decided to point here for its FD, but the Fastbin points here. I'm sure if you're exploiting this, you'd figure that out, but it's a good thing to know about. And the other difference between the Fastbin and the tcache is there's no key protection, and so the double free protection is different, like we talked about in the previous module. The nice thing about the key, though, is up until like 2.35 or 2.34, it was actually a pointer of the tcache itself, which led to a whole series of techniques called the House of IO, which I don't have time to cover in this course, but it's interesting nonetheless if you want to look it up. But it also was good for a heap leak, because the tcache is on the heap itself, and so if you could read that variable, you could get a heap leak out of it as well. But that's tcache, not Fastbin. So I have some code right here. That's there we go. I have some code right here that you can also look at. I can remove the camera for a second. So in this code snippet, this is actually, I'm not going to tell you what it's doing, because that's the whole point of the code review. NB is a size requested by the user. The victim, I'm not making this up, this is what actually is going on. This is the chunk being removed by the bin. And then the Fastbin index is the index of the Fastbin that it should be checking. So what is this check in that if statement actually doing here? I think this is a good way to become more familiar with the malloc source code, because inevitably if you're doing exploitation, you're not going to fully understand it. You're going to have to read it, and getting your feet wet here and there is, I think, really helpful. You can pause the video if you want to. All right, we're going to try the next thing now. So what's happening here is that we're validating the size of the chunk being removed matches the size of the bin. And this is where the actual check happens. So for instance, if I somehow got a chunk of size hex 60 into the hex 50 bin, it would crash. But what this actually is most useful for is the FD poisoning technique I talked about before. If you try to put data for like a function pointer as this pointer, there's unlikely to be a valid chunk size at that location for the corruption you did. So it makes the FD poisoning technique substantially harder to do. The way it actually does this is the IDX, like I said, is the index of the chunk that it found, and then it's checking for the chunk size that we were actually in the first place. So it's checking the actual chunk right now, and then the IDX is the actual location which we're taking the chunk from. So this happens not on the addition, but on the removal of the chunk itself. The other thing I think is kind of fun to talk about that may not be as useful now, but was useful for a long time, is prior to 2.31, there was no alignment checks on chunks that were being removed. And this is really interesting. So what people found out was that right before the malloc hook, there were actually valid chunk sizes you could use. So to clarify, I guess I haven't talked about this in the past, but with there were various hooks in malloc in order to do extra diagnostics and things. And the malloc hook is one of them. There's malloc hook, free hook, and a couple of other hooks, and I plan on talking about this in a different module, just for context. So, if you look at like this 7F right here, if we misalign that, we can actually use a 7F as a valid fastbin. And although you can only put this in that one location, it's still really helpful. If I turn off my camera, you can see what I've done here. We can see that here we're doing from B0, and from here we're doing from D. So we've misaligned it, and we're checking on this. And if we put this this address into the largest fastbin, it actually would work. The 7F here is very useful in this case, and it acts as a fake chunk size. So then later when we write to this, we can actually write to the malloc hook, corrupt it, and if you can change it to be an arbitrary value, then you can cause all sorts of havoc, which is awesome. Cool. So that's all I had for the fastbin section. Just wanted to talk about a few little tricks and interesting historical things. Thanks for watching.